All right. Let's have question number 6. Okay, just hold on just a minute. All right, I am back. So the question number we are starting with is number 6, and it says, consider the following pair of table that you have been given right on the screen. And on the right hand side, you have the states of nature. The left one, you have the decision techniques. And then you are required to assume you are a decision maker. And now that you're a decision maker, you are to face the following uncertain conditions. What decision are you going to choose given the different states of nature that you've been given? So you have these alternatives, you have these options that you have. How many are there? You have decision 1, decision 2, 3, 4, 5, and 6. Those are just the decisions that you have. And on top, you have the states of nature, yeah, of which you do not have control over them, right? You don't have control over the decisions or over these states of nature. So you are to choose and make their decisions. That's what the question is requiring you to. But let me just lay a background to this topic. The name of the topic is called decision-making techniques. Okay, it is decision-making techniques. What you're trying to do is, in this world where you have quite a lot of happenings, quite a lot of occurrences, you need to be able to make right choices given various alternatives that might before you. So what is happening is that now you are in a valley of decisions and you have so many routes to take, right? You are thinking, maybe I can do this, maybe I can do that. And as you're doing that, you're also limited or you're under control of the states of nature. These that you don't have control over them. These are underlying factors. So what decision do you make given that there are these states of nature that you don't have control over them? Just have to accept them the way how they are. So which route do you take? Okay, which route do you take? So there are basically different methods, of making such decisions, and these are they that were given. The first one is Laplace criterion, Max-Min criterion, Max-Max criterion, and Savage criterion, Hockweg criterion, and that is the last one. So these are different criteria that you are making when making decisions, that you can use when making decisions. Okay. Can you confirm you can see the screen and can hear me up to this far?
Yes, I can see the screen and I can hear what you're saying.
Okay, that's fine. Let's continue then. So let's start with the first one. How do you make decisions when you are using Laplace criterion? What you need to understand is that the Laplace criterion assumes that all states of nature are equally probable, right? To apply the method, what you need to do is just to compute the average or the mean payoff for each decision alternative. So you need to do the average for each payoff, do the average for each payoff, and then after doing the average for each payoff, you are going to choose the maximum average. So what we are trying to say is the following are the payoffs or the decisions. Decision number 1. So these are the workings that you're doing. For decision number 1, you're going to say 7 plus 6 plus 9 plus 11 plus 10 and plus 12. Let's hope we are not going to miss anyone. And number 7, 6, 9, 11, 10, and 12, right? 7, 6, 9, 11, 10, and 12. Then divide that by 5. That's how you find the mean, the average. So let's find the average for this first decision.
Why are we dividing the what is The average.
We are finding
by
the
5.
average. Yes,
Why are
I'm
we
saying when
dividing
you're
by
using
5?
when you're using this criterion, you need to compute the averages for each decision. The averages, the means, in short, or the expected values for each of the decisions, and then you will compare the averages, right? You're going to choose the highest score, all right? The highest Laplace score. The Laplace score is this same mean that you're calculating, okay?
Okay, my question is that the numbers of that when you count it from 7, 1, 6, 2, 9, 11 plus 12, it's giving me 6, but you are dividing by 5. Where have you gotten the 5?
Oh, there are 6. Oh,
Yes.
okay. I didn't see
1,
that.
2, 3, 4, 5.
There are
There are
1, 2,
6.
3, 4, 5, 6. Good question. Yeah, they are to be divided by 6 then. So you count by how many they are, count them, then you divide.
No, count.
So what is the total?
Sorry, I don't have a calculator with me. Remove it.
Okay, so when you consolidate this, they should be able to give you 55, and you divide by 6, that should give you approximately 9 some, right? 9 point something, because the 6 goes into 54. It goes into 54 9 times, right? Then remainder 1. So when you add a 0, it should be 9.1 something short. So this is your mean for this first decision. Then we go to the next decision. We're going to calculate the mean as well, or the average score.
But, sir, is it not supposed to, oh, there's a 10. Okay, okay. So suppose 55, we divide by 6. Okay.
All right. And then from there, you go to the second decision, which will add 8 plus 7, plus 12, plus 7, plus 6, plus 10, isn't it? And divide by 6. Didn't we miss the numbers? 8, 7,
No.
12, 7, 6, and 10 to be divided by 6.
That's 8.3. Okay, let me calculate.
8.3. 8.33, that's the mean. Now, I hope you're keeping the means. You always listen to our classes with a book and pen. The second decision has the mean 8.33. Let's go to the third decision. The third decision will be made up of what numbers are we using? 12 plus 10,
10.
6 plus 8 plus 9 and plus 12, and all that to be divided by 6.
That's 9.5.
9.5.
Yes.
That's nice. 9.5. That's the third decision, huh? Let's go to the fourth decision. You'll have 7 plus 14 plus 11 plus 6 plus 7 and plus 11 to be divided by 6.
That's 9.3.
9 is 9.3 as well.
Yeah, 9.3. Which one was 9.3 as well? That one was 8.3 for decision 3. It was 8.3.
Okay, 8.3, 9.3, Then decision 5.
Decision 5. Yeah, 5, 6, 8, 10,
10,
11,
12 divided by
and
6.
13. This is 8.8.
8.8. Let's do decision number 6, the last one.
Okay, 9, 12,
What do you get?
9.6.
9.6.
Mm.
All right, 9.6. So you look for the highest score, right? The highest Laplace score. That is the decision you take. So which decision are you going for?
The high score. Is it not the same 9.6?
Yeah,
The
so
highest.
decision number 6 has got the highest Laplace score, and for that reason, we are going to take decision number 6 using Laplace criterion. Okay?
Okay.
That's part A. So the most important thing to take home is you always move along the decisions when you're dealing with the Laplace score. In case your table is inverted, that is to say the decisions are on top. For example, you find decision 1, this becomes decision 2, decision 3, decision 4, decision 5, and decision 6. Then these become the states of nature. I want you to see.
But the
Okay.
one is.
So you move along the decision. So when adding that time, then you'll be adding vertical like that, or you'll be using columns. So you say 7 plus C 80 plus C 12 plus 7 plus 5 plus 9. You get what I mean, eh? And divided by how many? That is, you follow the decisions. You move along the decisions, in short.
Okay.
Decision-making techniques, we are on B. It says using max-min criteria. Which decision are you going to use? Now, when you're dealing with max-min criterion, you
Sorry,
select
sir,
the
I have a
alternative.
question. Sir, I have a question on Laplace criteria. Like, is it always that we have to find the average of all the decisions for us to find the Laplace?
Yes, that is how you find the Laplace score. You need to find the
So
Laplace
even
score and
during
choose
the
the
exam,
highest.
you have to show the work for all the all the averages for the decisions.
Yes, that's how you decide which one. You have to show your work. Show which. How did you decide? How did you know that this one is the highest score? Because you get the highest Laplace score.
Okay.
Now, when you are using max-min criterion, now we read these words from max-min from right to left. So I'll explain what I mean. Right to left, not left to right. So the first thing you start with is to find the minimums of these scores. In each of the decisions, look for the minimum, right? Minimum. Then afterwards, you choose the maximum from the minimums. That is how you use max-min approach. The clue is, please read it from right to left. Start with the minimums, then get the maximum. We are good?
Yes, sir.
Okay. Now let's go ahead and start with the first decision. What is the minimum score in the first decision?
It's 8.
Minimum. Decision 1. We are moving
Oh,
along the
decision 1.
like that. not the states of
okay.
nature, along the decisions.
Okay. It's a 6.
I guess 6 should be the minimum. Then when you go to decision number 2,
Decision number 2 is a 7.
are we certain about that?
Yes. Oh, it's 6, sorry. 6. I didn't see the 6.
Decision number 3,
6 also.
it is 6 as well. Decision number 4,
It's also
still
6.
6. Decision number 5,
5.
5, and decision number 6,
8.
the highest, or the
Okay.
minimum, sorry.
The minimum is
minimum.
8.
Yeah, it's 8. So now, from these minimums, you choose the maximum. What decision are you going for? Using maximum.
It's decision 6.
You're still going for decision 6, right?
Mm-hmm.
Any questions?
I just want to be clear on this one. You said like the max mean is first starts by looking the mean or the lowest number of the scores in all the decisions, right?
Mm-hmm.
And then after you find the lowest number, after you list the lowest numbers, then from the list of the lowest number you find the decision which has the highest score. That's the way it's supposed to be.
That is. Oh, that is.
Okay,
Yeah.
thank you.
Let's go to 6. What is this? The third decision, that's max. Max. This is an optimistic approach. That is the other name. In case you find an examiner, another examiner uses optimistic approach, is the same thing, right? Max approach. Now, with max approach, as the name may be suggested, I told you, you read from right to left. So you start by looking for the what? For the maximums. And then you get the maximum again. Did you get
You
it?
start looking for the, sorry?
Maximum.
So
Maximum
from the
number one.
left, max.
So we'll go again. Decision number 1. What is the maximum score? It is
Maximum
12.
score 12.
Decision number 2 is still 12. 12 number 3, yeah?
Mm-hmm. 4 14.
14.
5 13.
13.
7 6 12.
Then again, what do we go for? We go for the maximum. It's max.
Okay.
So the highest score is on which decision?
It's on decision 4.
Okay, decision number 4. That is. Any questions?
No. No question.
I am back. We are
Okay.
choosing decision number 4, yeah?
Mm-hmm.
Okay, that's fine. Let's go ahead and look at the Savage approach, Savage criterion. How do you make a decision now using Savage criterion? It should interest you to learn that the Savage criterion is also called minimax regret. Minimax regret or regret criteria. That is how others call it. Minimax approach or regret approach. It is also called the Savage criterion. So please, you have to be conversant with these names, right? Or these terms I'm using, because when you meet maybe some other examiners, they may opt to use them, and then you start getting lost. You're like, what is it that they are looking for now? Okay.
Hello.
Yeah.
Yes, I got lost on the minimax. You said that the name for minimax, the other name is what?
Regret approach. Regret
Okay.
or Savage. It's the same one on D. Savage criterion.
Okay.
All right. And we proceed from here. Let's progress. What we're going to have now is we need to form, there is what we call a regret table or a regret matrix, right? Now listen carefully. When you're forming a regret matrix, you have to move along the states of nature. It's different from these other approaches where you're moving along the decisions, right? Here you move along the state of nature. And so, for example, the first state of nature is this one. So you're going to look for the highest score from this one. What is the highest score? We want to form the regret.
12.
It's 12, right? So you are going to deduct all these other numbers from 12 in the first state of nature. Let's go. So we are forming a regret matrix. So say 12 minus 12 is 0, right? Then 12 minus 8 is what? Is 4.
12 minus 4.
12 minus 7 is 5. It's 5 here again. 12 minus 5 should be 7. And 12 minus 9 is 3. You're following?
Yes.
And again, when you come to the second state of nature, what's the highest score? The highest score should be 14, yeah?
14.
14 minus 14 is 0. 14 minus 10 is 4. 14
4.
minus 7 should be 7, right? Is it?
Yes. 14 minus
14
6.
minus, yes, then
8.
14 minus 6 should be 8. And the 8 again here down, right?
Then 2.
And then 2. When we get to, which one is this now? Set of nature number 3. What's the highest score?
The highest score is 8.
8. So we shall say, is it the highest score, not the lowest score on the state of nature number 3?
The highest score from the what is? It's 8.
From state of nature, S's.
Oh, okay, from S3, okay. It's 12.
12. 12 minus 12 is 0. 12 minus 6 should be 6. 12 minus 11 is 1. 12 minus 8 is 4. And 12 minus 12 is 0. and here it is 3. Hope you're following and you're not getting lost. Regardless of
No.
how the states of nature are put, if they are put in rows, please do the same. Okay, the message is move along the states of nature. Now, when we get to the state of nature number 4, the highest score being 11, you shall say 11 minus 11 is 0. 11 minus 7 is what?
4.
4. 11 minus 8 is 3. Minus 6 should be 5. Minus 10 should be 1. And minus 9 should be 2.
2.
State of nature number 5, the highest score being 11. 11 minus 11, 0, right? 11 minus 7 being 4.
11, 4.
3 here. And 11
2.
minus 9 is 2.
2.
11 minus 5, minus 6 being 5, and minus 10 being 1. And 13 is the highest score in the last column. Right.
Yes.
13 should be the highest. So you say 13 minus 13, 0. 13 minus 8 is what?
13 minus 8 is 5.
5 minus 11.
Minus 2.
Minus 12 should be 1. Minus 10 should be 3.
3.
Minus 12 should be 1.
1.
Now, this is called the regret matrix or the regret table. Yeah, depending on the literature that you are reading. And so you have to move along the states of nature. Now you have to move along the decisions when you're making the decision. And this is, we say it is called the minimax. You have to start with the maximum, right? And then the minimum. What is the maximum score in decision number, what is this? 1. It's 8.
8, yes.
And the maximum in decision number 2?
8. Are you looking at the decisions or the what?
The decisions. Now we are moving along decisions. The states of nature, we are just performing the matrix. The matrix has been formed. What's the highest score in decision number 2 should be 7, yeah? Decision number 3, what's the highest score? 6. Decision number 4, the highest score is 5. The highest score on decision number 5 is 8. And the 5, and the 5 in the last one. What do we choose next?
The mean.
The minimum.
Score.
And which one is the mean score?
In decision number 1, it's 1.
Sorry?
In decision number 1. Oh, okay.
I mean, which one is the minimum score from all these?
It's a 5.
5 is the minimum score, which means that a person could either go for decision number 6, right? Or decision 4. They all have 5. However, you have to redo this at your own time, I guess, just to counter check if the numbers, the way how we were doing it, we never made any mistake. You get what I mean? Because if you make a mistake when you are making this table, then you may make a wrong decision. But the most important thing is to know how it's done. I think that's you still have to redo these at your own time and counter check. Okay?
Okay.
So decision 6 or decision 4 has the minimum regret. The Herwick criterion that has got the alpha of 60% is what we need to do now. That's the last one.
Sorry, sir, I have a question on savage criteria. Like when when you're sorting this one, you have to form your own table.
Yeah, that is. You have to form a regret matrix, not your own table. This is a question, but the regret matrix, you have to form it from this table. I showed you how to form it. That one is called a regret matrix. That's the one that you use.
Okay.
So now the Herwick matrix is given as following. You have alpha to multiply by maximum. Let me just put it like this. Alpha times maximum plus C 1 minus C alpha times the minimum. This is the formula for getting the Herwick criterion score or the Herwick score. Okay. So the maximum for each of these decisions, we'll start with, for example, decision number 1. Let's start with decision 1. What is the alpha is 0.6 times the maximum score is what? Is 12, yeah? In decision number 1. 1 minus 0.6. The minimum score being?
7.
6. There is 6 here.
6, yes.
Then you do your working out. 0.6 times 12 plus 1 minus 0.6 is 0.4, yeah? So 0.4 multiplied by 6. So you do that calculation. What is the Herwick score? 0.6 times 12?
0.6.
Plus 0.4 times 6.
That's 15.9.
I doubt. You can try to do it again.
Okay. Nine point
9.7. Okay. Okay, what is 0.12 or 0.12 or 0.6 times 12? What do you get?
0.2. I mean 7.2.
7.2 plus what is 0.4 times 6?
0.4 is 2.4.
2.4. Then you can add these together.
9.6.
9.6, not 9.7.
Yes. Okay, 9.6. Sorry, I made a mistake.
This is the score. Then we can go now to the next decision. I guess you have picked the message. You do the
Yes.
same when you go to the second decision. 0.6 alpha times the highest score is 12,
The
right?
highest score is 12.
Plus 0.4 times the lowest score is 6.
Where are we getting the 0.4?
1 minus alpha. You've forgotten the formula. I had written is the alpha times the maximum, you know, plus the 1 minus the alpha times the minimum. This is the formula.
Oh, okay.
What do you find? I guess this is the same computation. It's the same figures that we found previously. So it will still be 9.6. Even when you come to D3, the highest score and the minimum score is still the same. So it will still be 9.6. Right. Yeah. D3, the highest score, the minimum is 6. Also here, highest score, the minimum is 6. So it will give us the same. When we go to D4,
highest is 14. So 14.
0.6 times 14
plus
plus
1 minus
plus
1
0.4
0.4
times the minimum is still 6. What do you get?
or 10.8.
10.8. All right. Then we go to the next one. D5. What's the highest score?
13. 0.6 divided 5.
5.
Finish question. Mm-hmm.
What do you find?
So means 9.8.
Then 9.8. Okay. Decision number 6.
12. The highest
So it's 0.6 times 12 plus 0.4 times what? 8.
should be 10.7.
You can do it again. 0.6 times 12, we found 7.2. Can you do 0.4 times?
10.4.
10.4. Yeah. So you choose the decision that gives you the highest score. Which one is the highest one?
The highest. I wasn't even writing. Is it not 10.7?
10.8.
10.8?
Yeah. It is from
From
decision number 4.
decision. Yes. Oh, yeah, yes.
So you will go for decision number 4.
Mhm.
So you could see that the overall best choice is decision number 6. Is the one that most of the criterion have chosen. Right?
Yes.
Any questions?
Okay. So like when you are trying to find the horizontal criteria, when you find what is the maximum, the decision which has the highest score, which you are find to be 10.8. So when you want to write the answer, how do we how do we put it?
Because after work, you say, therefore, choose decision D4, which is decision 4, right?
Okay.
Because it has got the highest. Here is
So you just go like therefore.
Therefore, you choose decision 4, D4, like this.
Oh, okay.
Because it has the highest score, the Harris score is equal to 10.8.
Okay.
Consider.
No question.